Jai Shri Gurudev. Good morning to everyone, students. The next concept is wave nature of electromagnetic radiations or Planck quantum theory of radiations. Here, the phenomena such as interference, diffraction, polarization, all these are explained by wave nature of electromagnetic radiations, and the phenomena such as black body radiations, photoelectric effect and line spectrum of hydrogen atom, these could not be explained by wave nature of electromagnetic radiations. Okay. However, the phenomena such as black body radiations, photoelectric effect and line spectrum of hydrogen atom is explained by particle nature of electromagnetic radiations. Here in this class we are going to study how the phenomenon like black body radiations and photoelectric effect is files to explain wave nature of electromagnetic radiations and how it is good to explain by particle nature of electromagnetic radiations. Okay, that is the aim to understanding in this class. Now take first one, black body radiations. That is black body radiations. Here black body is nothing but a perfect ideal body which can be absorbed or emitted all radiations of wavelength is called black body. Okay, black body is nothing but a perfect ideal body which can absorb or emitted all radiations of frequency is called black body. Okay, for example, metals, take iron. Any substance or any matter which could be absorbed or emitted radiations, such type of body is called black body, and the radiations emitted from the black body is called black body radiations. So here we are taking example iron metal. Now let observe here. When the iron metal is on heating, it becomes red hot plug. On that time, the iron emits red radiations, which is on again heating, the red iron becomes white hot plug, or it becomes white. During that time, it emits white radiation, which is on further heating, it becomes blue. So at that time it emits blue radiations. It means the iron rod can absorb all radiations, means light radiations and heat radiations. Here it absorbs all heat radiations and it emits the respective range of wavelength radiations that we call black body radiations. It means the radiations that is emitted from the iron rod when it is red or white or blue, that is called a black body radiations, and for those radiations has a definite frequency and wavelength. Okay, so here while we are plotting graph from frequency versus temperature, we get a curve like that. When we are plotting graph temperature on x-axis and frequency on y-axis. So here temperature in kelvins and frequency in hertz per second. So when plotting graph for iron rod or any substances with the temperature versus frequency, you get a curve like that. So let us see, this is the curve. We obtain when iron is on heating, it becomes red hot. ಅಂದ್ರೆ ಐರನ್ ಅನ್ನು ಹೀಟ್ ಮಾಡಿದಾಗ ರೆಡ್ ಅಂದ್ರೆ ಕೆಂಪಿಗೆ ಕಾಯಿದಾಗ ಈ ತರ ಕರ್ವ್ ಬಂತು. ಸೊ ಹೌ ಇಟ್ ಈಸ್ ಗೆಟ್ ಅಬ್ಸರ್ವ್ ವೆನ್ we are heating iron metal we are heating, if this iron metal becomes what? Red hot iron. So here we are increasing the temperature, means we are supplying heat to this metal until it becomes red hot. So while increasing the temperature, means temperature is increases, frequency also increases, it becomes red. So at this frequency and temperature, means at this temperature and this frequency, the iron becomes what? Red hot iron. So again we are increasing temperature, the frequency is decreases. So again, and we supplying temperature to this red hot iron, it becomes what? White iron. It becomes white iron, means not white iron. The color of the iron rod is changes. It means the intensity is changes. For that you get a curve like that. Means the frequency of white radiations is higher than that of the what? Red. So again it is until it becomes blue, right? This is means blue iron rod weight. So its curve is like that here. It means at certain temperature, means up to certain temperature, the frequency is maximum. Again, when we are supplying heat, the frequency is decreases. Then again it will be increases when we changes to one state to another state. Not it is actually state. One color intensity to another color intensity. So this is called black body radiations. Okay, and here defense observe the main factor is the temperature is dependent on, so frequency is dependent on temperature. This is called black body radiations. And here, after studying black body radiations, the Planck's scientist gives some postulates and what he observed on this. That will be explained later after knowing the photoelectric effect. So the next concept is, means next topic that will be explained the particle nature of electromagnetic radiation is photoelectric effect. Here this is the set of arrangement to explain the photoelectric effect. This tube is called as vacuum chamber, this glass tube is called vacuum chamber, and this is the metal strip, and here the ejection of electrons from the surface of the metal, that is electron ejection, and these lines for incident of light, and this is the detector. This detector detects the electrons emitted from the metal surface, and which is connected to a meter that is called ammeter. Here writing A. So this indicates the amperes, means current voltage in amps, and this is the battery. We are supplying current, means heat energy or electrical energy to the metal to eject electrons. So here the photoelectric effect is defined as the process of emission of electrons from the surface of the metal when suitable frequency of light radiation is hit on the metal or hit to metals. That is called photoelectric effect. So photoelectric effect is defined as the process of emission of electrons, from the surface of metal when suitable frequency of light radiations is hit on a hit to metal. Hit on metal is called what? Photoelectric effect. Is called photoelectric effect. So this is the definition of photoelectric effect. So here the metal has minimum energy to emit electrons. Below that the photoelectric effect couldn't be explained or not takes place. Okay, andre ಒಂದು ಮೆಟಲ್ಗೆ ತನ್ನದೇ ಆದಂಥ ಒಂದು ಎನರ್ಜಿ ಇರುತ್ತೆ. ಅಷ್ಟು ಎನರ್ಜಿನ ನಾವು ಸಪ್ಲೈ ಮಾಡಿದಾಗ ಮಾತ್ರನೇ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನೋದು ಎಮಿಟ್ ಆಗೋದು. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನೋಡಿ, ಐರನ್ ಅನ್ನ ಹೀಟ್ ಮಾಡ್ಬೇಕಂದ್ರೆ 1073 ಕೆಲ್ವಿನ್ 1073 ಕೆಲ್ವಿನ್ ವರೆಗೂ ನಾವು ಹೀಟ್ ಮಾಡಿದ್ರೆ ಐರನ್ ಏನಾಗುತ್ತೆ, ಕೆಂಪಗೆ ಆಗುತ್ತೆ. ಇಲ್ಲ ಅಂದ್ರೆ ಅದ್ರ ಕೆಳಗಡೆ ನಾವೇನಾದ್ರೂ ಹೀಟ್ ಮಾಡಿದ್ರೆ ಅದು ಕೆಂಪಗೆ ಆಗೋದಿಲ್ಲ. ಅರ್ಥ ಆಯ್ತಲ್ವಾ? ಆ ರೀತಿ ನಾವು ಏನ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಯಾವುದೋ ಒಂದು ಮೆಟಲ್ಗೆ ಅದಕ್ಕೆ ಎಷ್ಟು ಬೇಕು ಅಷ್ಟು ಎನರ್ಜಿ ಸಪ್ಲೈ ಮಾಡಿದಾಗ ಮಾತ್ರ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಲ್ಲ ಎಮಿಟ್ ಮಾಡೋದು. ಅದ್ರ ಕೆಳಗಡೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಮಿಟ್ ಆಗೋದಿಲ್ಲ. ಅದನ್ನ ಏನಂತ ಕರಿತೀವಿ ಅಂದ್ರೆ ಥ್ರೆಶೋಲ್ಡ್ ಎನರ್ಜಿ ಅಂತ ಕರಿತೀವಿ. ಮೀನ್ಸ್ ಎನಿ ಮೆಟಲ್ ಆರ್ ಸಬ್ಸ್ಟೆನ್ಸ್ that has its own energy or minimum energy, below that the photoelectric effect couldn't be takes place. That energy is called as threshold energy. So here when we are supplying the minimum amount of energy that should be required to the metal, then the metal gets start to eject electrons from the surface of the metal. ಅದರ ಸರ್ಫೇಸ್ ಮೇಲೆ ಇರುವಂತ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಏನಾಗುತ್ತೆ, ಸರ್ಫೇಸ್ ಮೇಲೆ ಇರುವ ಯಾಕೆ ಹೋಗಬೇಕು ಅಂದ್ರೆ ಯಾವುದಕ್ಕೆ ಜಾಸ್ತಿ ಎನರ್ಜಿ ಬೇಗ ಸಿಗುತ್ತೋ ಅದೇ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಏನಾಗುತ್ತೆ, ಎಜೆಕ್ಟ್ ಆಗುತ್ತೆ. That ejected electrons is detected by the detector and it also measures the kinetic energy of electrons. ಇದೇನಾಗುತ್ತಲ್ಲ, ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ನ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿಯನ್ನು ಕೂಡ ಮೆಜರ್ ಮಾಡುತ್ತೆ. ಓಕೆ, this kinetic energy and number of electrons is detected by detector, and we are seeing how much current is passes to this metal. This is the battery, and positive and negative electrons means hands, and this is indicated by battery PA, and this is vacuum chamber. Means this one is vacuum chamber. Inside that we are kept a metal piece. Okay, this is the set off. Here the amount of energy is hit on the surface of the metal. It emitted electrons. That electrons is detected by detector, and it also gives the kinetic energy of electrons. Below that energy, the photoelectric effect couldn't be take place. That is called threshold energy. And the ejected electrons energy is directly proportional to the frequency of incident radiations. Ejected electrons energy is directly proportional to the frequency of incident radiation. This is the photoelectric effect. Here the photoelectric effect takes place or occur the metals which has a less ionization energy, that is only the alkali metals, that is the metals such as, very important, the metals such as sodium, potassium, rubidium, cesium. These only shows photoelectric effect. ಈ ಮೆಟಲ್ಸ್ ಮಾತ್ರ ಫೋಟೋಎಲೆಕ್ಟ್ರಿಕ್ ಎಫೆಕ್ಟ್ ಅನ್ನು ಜಾಸ್ತಿ ತೋರಿಸುತ್ತೆ. ಯಾಕೆ ತೋರಿಸುತ್ತೆ ಅಂದ್ರೆ ಅಬ್ಸರ್ವ್ ಮಾಡಿ, ಸೋಡಿಯಂ, ಪೊಟ್ಯಾಷಿಯಂ, ರೂಬಿಡಿಯಂ, ಸೀಸಿಯಂ, ಆಲ್ ದೀಸ್ ಆರ್ ಕಮಿಂಗ್ ಅಂಡರ್ ಎಸ್ ಬ್ಲಾಕ್. ಇನ್ ದಟ್ ದಿ ಫಸ್ಟ್ ಗ್ರೂಪ್, ಇವೆಲ್ಲ ಫಸ್ಟ್ ಗ್ರೂಪ್ ಅಲ್ಲಿ ಬರೋದ್ರಿಂದ ಅವುಗಳ ವೇಲೆನ್ಶಿಯಲ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಏನಾಗಿರುತ್ತೆ, NS1 ಆಗಿರುತ್ತೆ. ಹಿಯರ್ ನೋಬಲ್ ಗ್ಯಾಸ್ ಅಂಡ್ NS1 ಕಾನ್ಫಿಗರೇಷನ್ ಆಗಿರುತ್ತೆ. ಸೊ NS1 ಕಾನ್ಫಿಗರೇಷನ್ ಆಗಿದೆ ಅಂದ್ರೆ ಔಟರ್ ಮೋಸ್ಟ್ ಶೆಲ್ ಅಲ್ಲಿ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದೆ, ಒಂದೇ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಇದೆ. ಒಂದೇ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಇರೋದ್ರಿಂದ ನಾವು ಸ್ವಲ್ಪ ಎನರ್ಜಿಯನ್ನ ಸಪ್ಲೈ ಮಾಡಿದ್ರೆ ಸಾಕು, ಬೇಗ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನೋದು ಎಮಿಟ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ಸೊ ಡ್ಯೂ ಟು ದಿ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ಓನ್ಲಿ ಒನ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇನ್ ಎಸ್ ಶೆಲ್ ಆಫ್ alkali elements, by supplying less amount of energy, it ejected electron easily. Therefore the alkali elements or alkali metals has ability to show photoelectric effect. Okay, so these are the metals. So very important for 1 marks. They ask give any one example for metal that shows photoelectric effect like that. Okay, so this is the photoelectric effect. Now by observing these two effects, means photoelectric effect and black body radiations, the Planck gives some postulates that is called Planck quantum theory postulates that we are studying now. So that is postulates of Planck's quantum theory. Postulates of Planck's quantum theory. The first postulate is the radiant energy emitted or absorbed in the discontinuously in the form of small packets of energy is called as quanta or photon. Very important. First one, the radiant energy. The radiant energy emitted or absorbed discontinuously in the form of small pockets of energy called photon or quantum. Okay, so this is the first postulate. The radiant energy is nothing but electromagnetic energy. He is emitted. It will be emitted from the metal, or it will be absorbed from the metal or any substances at source. That will be discontinuously. It is not continuous. It is not like it is in the towel, either straight line or like curve. It is not. It is only discontinuously like that. Discontinuously like particle. Okay, not like wave. It is discontinuously in the form of small packets. Like you take, this is a pot of energy. In that there is a small packets of energy. This is the small packets of energy. These are the small packets of energy, and this is the whole packet of energy. This small packets of energy is called what? Quantum or photon. This is the first postulate. Then the second one. The energy is directly proportional to the energy of each quantum or photon is directly proportional to the frequency of incident radiation. So that is the energy of quantum or photon is directly proportional to the frequency of radiations. That is the second postulate. So here the mathematically it can be written as energy is directly proportional to the frequency of radiations, and this can be implied E is equal to H. Okay, by removing proportionality constant we are writing H. So H is called what? Planck's constant. Already I told you Planck's constant, and its value is how much? 6.625 into 10 to the power of minus 34 joules second. 625 into 10 to the power of minus 34 joules second. 6.626 into 10 to the power minus 34 joules second. This is the energy of constant of H, that is Planck's constant. And the third one, the energy of photon is directly proportional to the frequency, and it is integral multiplier or half integral multiplier. That is the third postulate. That is the total amount of energy emitted or absorbed by the metal is directly proportional to the integral multiplier of frequency. That is simply written as He is directly proportional to the NhU integral, where N is nothing but integral. That is 1, 2, 3, so on like that, starting from 1 to 3. So this is the integral up to infinity. Okay, this is the three postulates. These three postulates is given based on the black body radiation. Black body radiation nodibittu Planck's and the three postulates alla kodtare. Then the fourth one, that is based on the photoelectric effect. The number of electrons emitted from the surface of the metal is directly proportional to the frequency of incident radiations. That is the fourth postulate. The number of electrons emitted from the surface of metal is directly proportional to the frequency of incident radiation. Frequency of incident radiation. This is the fourth postulate, that is based on the black body radiations. And the minimum amount of energy that will be associated by metal is called threshold energy. The fifth one is the minimum amount of energy The minimum amount of energy that should be required to cause photoelectric effect is called threshold energy. The minimum amount of energy required to cause photoelectric effect is called threshold energy. Threshold energy, that is indicated by nu naught. Nu naught is the threshold frequency and the energy is E is equal to h nu naught. This is the threshold energy, where nu naught is what? Threshold frequency. This is the fifth postulate of quantum theory. Then sixth one, the kinetic energy is directly proportional to the frequency of incident radiation, that is frequency of threshold energy, threshold frequency. So here, you know, already I explained the photoelectric effect. This is the glass tube. Here there is a metal strip and here there is a detector. The electrons emitted from the detector. So the electron emitted from the metal is detected by detector, and it also measures the kinetic energy of these electrons when we are incident suitable frequency of radiations, right? This is collected by an ammeter and which is connected to a battery, like that. We are explaining photoelectric. Similarly, here the kinetic energy is directly proportional to the frequency of incident radiation. That is given by the mathematically kinetic energy E, or that is equal to kinetic energy is nothing but what? Of mv square, that you studied in physics and as well as in chemistry. So kinetic energy of mv square is equal to h nu naught, that is frequency of light radiation minus threshold frequency h nu naught. This is the kinetic energy mathematical equation. Okay, so of mv is nothing but what? Kinetic energy. So here of mv square is equal to kinetic energy Ke, that is equal to h is common, mu minus mu naught. This is the kinetic energy of the particles emitted from the surface of the metal. Metals in the one electron emitted after the kinetic energy into intensity of incident light agirutte matte emitted electrons na frequency agirutte. So these are some postulates of Planck quantum theory that given by Planck after studying photoelectric effect and black body radiations. Now we are going to some of the problems based on these formulas.